In this video, we're going to learn how to interpret scatter plots. A scatter plot tells us about the relationship between two variables. This graph here is a scatter plot showing the relationship between the mass and height of Star Wars characters. Each point on this graph is a particular Star Wars character, and each of those characters has some value for the mass variable and some value for the height variable. And the point for that character is located where those two values intersect. So once we've created this kind of graph, how can we go about describing the sort of relationship that we see here? Well, one of the first things we can say is whether or not that relationship is linear. The concept of linearity is kind of intuitive, right? It's like a straight line. And more specifically by that, we mean that you can draw a line through the data that has a constant slope all the way along the line. The alternative is if the data is nonlinear, i.e., if the line that's best drawn through the data is curved, like you see on the right here. More precisely, we would say that the slope of this line is variable. If we have a linear relationship, we can characterize that further. We can say whether that linear relationship is positive or negative. This is determined by whether the slope of that line is positive or negative. So in the graph on the left, for example, you see a line that is moving upwards as we go to the right, and so that has a positive slope, and so we say the relationship is positive. Conversely, the graph in the middle has a negative relationship. If we happen to plot two variables and we find that the slope of the line through the data is 0, we would say that there is no relationship between these. In other words, it doesn't matter what the value of x is, y seems to have no relationship with x. Another thing we can say is how correlated the two variables are. The data can fall very tightly, very close to the line, like you see on the left here. We would say that's highly correlated. The data can also be very scattered, but still have a general linear trend, i.e. we can still draw a reasonably straight line through that data, even though the points are all a long way from the line, like you see on the right. So there's a linear relationship in this graph on the right, but the data is poorly correlated between the two variables. Make sure when you're interpreting your own graphs that you don't misinterpret poorly correlated data like this with there not being a linear relationship. Another common hurdle that can trip people up is when you have data like this. This data is linearly related. I created it explicitly so that it had a linear relationship. However, what you see is that the correlation between x and y is very good on the left-hand part of the graph and quite poor on the right-hand side of the graph. It can be easy to look at something like this and think, oh, there's not a linear relationship, maybe there's a curve. But no, if we were to draw a best fit line through this data, it would be straight. It would look something like this. So this is still a linear relationship. Let's go back to our Star Wars graph that we had on the first slide. How would you now go about describing this relationship? Well, there's an obvious problem with this graph, which is that there's one point very high up towards the top of the graph. But if we ignore that for a second and look at the rest of the data, it does look like there is a linear relationship between height and mass, which is what we'd expect, right? The taller you get, the heavier you probably are, even in a sci-fi universe. But the fact that we have this point very high up illustrates another use of scatterplots, which is to detect if we have data that falls far away from other points. We call these points outliers. So who is the Star Wars character that's causing this point? Well, if you look through the data set, you'll find that it's everybody's favorite villain, Jabba the Hutt, who, despite his fairly average height, is quite a bulky character.